what is blockchain technology? How does it help to create all kinds of data and not just cryptocurrency data? How is it better than any other kind of, let's say, legacy applications to secure and store data? Why I asked you is that in one of your LinkedIn courses, you covered it and really enjoyed that. But I really want just a little bit of more, explanation on that.
Well, we took a sudden corner from AI to blockchain,
Yeah.
which is great. Yeah, why not? Let's have fun with it. Yeah, I talk about another technology which has captured our imaginations, right? We didn't even hear the term blockchain, 11 years ago. And today, blockchain and cryptocurrencies roll off the tongue, very easily. So what happened? What is it? I'll try to give a very basic description of what it is. I think that's the first part of your question. There are many ways of describing it, and I think sometimes people who work in this space, they overcomplicate it when they give answers to people who maybe don't have the basis for understanding what they're saying. At some level, it is a way to store information about transactions, right? So just like a traditional relational database that you use, everybody uses on their computers, even though they don't realize it. We use databases to do just about everything in computing today. Blockchain can be considered a form of storing transactions. And so it's an alternative, right, to the traditional mechanisms. But the question then is, well, why do we care? Why is it different? Why would you use this blockchain technology, this way to store and move transactions between participants in a network? One of the things that it does well is, if you think about an existing or traditional database system, often the interaction with the data and the movement of data is initiated by humans. And the authority to manage the behavior of that data and the rules around that data are often human-based. Like, right. Let's take an example. When somebody wants to join a network, say they join an organization and they need access to an important database, usually a human being, some administrator, says, who are you? Why should I give you access? Right. And what kind of access do you need? And it's very human mediated, right? And so even though obviously it's a computing platform, the activities are very much human in the manner in which they take place. What blockchain does is it replaces a lot of that human interaction with code, with software. So some of these sort of big decisions we can codify. We can create code that essentially quickly makes choices about what can take place. For example, whether a person is allowed to participate based on their credentials, or whether a transaction can take place based on the rules of the network. And what you have is in a blockchain based network is computing, and the computational work is distributed among a lot of the participants on the network. So it creates a flatter hierarchy that ensures a more fair system, and one that doesn't rely on human bias or human availability or human error, but largely almost exclusively relies code to make things happen. So this is really valuable when it comes to things like a new form of money. So, right. The problem that a blockchain solved for digital money back in 2008 in the original Satoshi Nakamoto paper is how do you account for double spending? So if you have digital money, if I copy it, make a copy of it before I pay you, if I pay Vivek, $5, and then I just copy that $5 and pay somebody the same $5, well, you don't have an economic system. It doesn't work, right? The minute I pay you, I have to be without the $5, and you have the gain of the $5. How do you solve that, double spending problem? This is the core to what the magic was that created Bitcoin. And this is done again through this sort of unique architecture. You have a network that manages these transactions, right? In this case, it's a monetary transaction, and the system through code and the sort of consensus of the participating computers ensures that transactions are valid and they can't be repeated. And once I send you my $5, I can't do it again. That's what blockchain does well. So then to get to the last part of your question, well, beyond cryptocurrency, what is blockchain providing? So the sky's the limit is the answer to that. Every transaction that takes place today that perhaps is in some way burdened because of human engagement. Let's think about a mortgage, right? the joy of everybody's life. How do you go through the mortgage process to buy a house, right? I think everyone would agree it's painful, right? There's a lot of paperwork and there's a lot of people. There's lawyers, there's realtors, there's notaries, there's financial institutions. Think about all the participants. And, you've got to sign a lot of documents and mistakes happen and it's bureaucratic and it takes a long time. Okay. There you have a traditional human process that, some of it is clearly automated. We use computer systems, but still there's a lot of steps, a lot of participation. Now, if we go back to some of the principles of blockchain that I shared earlier, this idea that transactions are stored in a database and rules are guided by software, not by people, you could imagine that in the course of initiating a mortgage process, a blockchain network, a blockchain system might be better at more efficiently processing some basic requirements, right? By talking to other systems, by fulfilling the specificity of certain rules, and just, not waiting for a human being to press, approve, or to wait for humans to be signatories. The confidence we get in the blockchain network that we would typically have got in a human being is the fact that the software and the consensus of the participants ensure the integrity of every transaction. And so what you find then is in systems that are now trying to, for example, replace mortgages with blockchain technology, it moves faster, it's lower cost, and there's less errors. Now, of course, in the course of doing that, it displaces people. We're not happy about that. But, that there is a price to progress, and hopefully people move on to do other types of work. At the core, what I'm trying to say is, in a whole range of human-mediated transactions, blockchain has the ability to eliminate those intermediaries. And so we can do away with a lot of overhead and a lot of cost. And think about all the things in life that you deal with where a human being has to intervene. Imagine if you didn't have that, right? I think in a lot of cases, you'd actually be very supportive. And that's where we're seeing blockchain used in the healthcare world and supply chain. It's very big. And of course, financial transactions in cities, in autonomous vehicles and in the energy sector. So the role of blockchain has broad applicability and value across the economy.
Fantastic. Then on top of it, is it also more safer than a traditional database system because the transactions here are all non-human, and then you will have no control once it's going on through algorithms to algorithms. So is it more safer as well?
I like the question, and it's an important question. I can't give a quick answer to it.
Sure.
People would love me to say, "Oh yeah, it's safer."
Please go ahead. Yeah, take it.
That would be the easier answer, right? It would be more simple to say that. Nothing is that simple, unfortunately. Mm-hmm. The way you ask the question is really important. With less human intervention, with higher integrity in the way in which transactions are authenticated and processed, the assumption is, yes, in fact, blockchain has the potential to be more secure, to give us a higher degree of confidence in anything that may take place on it. And the evidence is, for the most part, it actually does improve the integrity of transactions. It does protect against some more traditional fraud and even, hacking attempts by cyber criminals. The evidence is that it does a better job of that just by its pure, design, the way it's architected. However, on the flip side, there are notable hacks, and unfortunately, cryptocurrencies and other blockchains have been subject to vulnerabilities. Now, part of this is because the technology is still evolving. It's still, technology that's emerging, and it's being innovated, and it's rapidly happening. There's a lot of people in the ecosystem, but it's early. I mean, the first time we see blockchain in its current manifestation is in 2009, right? A year after the Satoshi paper. So that means we're in 2021, we're like 12 years since this technology emerged. And we have a lot to be really, impressed by, the degree to which Bitcoin and Ethereum and even things like Ripple and other blockchain solutions have emerged and have been, in some respects, game-changing. But we're still really very much at the beginning, and we are seeing still a high degree of risks because of the technology. I think in the sort of medium to longer term, there is some evidence that data managed exclusively on a series of blockchains has the potential to be a lot more secure. And so, I'm optimistic, and I think we're heading in that direction. It's already demonstrating the possibility of that in just its reliability today. But the current weaknesses give me some caution. I think the whole topic of cybersecurity in general is an area of considerable innovation, significant risk today. Our systems are, because of the sheer number of new systems and new entry points, presents greater and greater risk to each of us and our organizations and to society. As fast as we innovate, the cyber criminals also are pretty smart and doing their thing. So it is sort of a constant race. Looking further ahead, I think we need to be thinking completely differently about how we secure data. I'm particularly intrigued by quantum cryptography, for example, and the quantum internet. The next generation of computing stack that through pure physics is going to make it much more difficult and in some cases impossible to hack.